So when you want to plot a scatter plot, one thing that you should know is that a scatter plot is used to represent two continuous variables. So the two variables that you want to plot, all of them should be numerical. That is very important for you to understand. So we want to plot a scatter plot using this data. We got data for daily sales and data for daily staffing. So as usual, we're going to go to insert, and then we have scatter plot here. So click on what are the simple scatter plot that we have at the beginning. So we'll have a blank. Click on the scatter plot that is blank, then select data. Go to the legend entries. So we'll have x-axis being daily sales, and we have the x values being all that. Next, we'll have the y variables being that. Then you click OK. So we'll have something like this. This is a scatter plot. On, let's try to add the axis. So click on the plus sign, and then you check the axis titles. Check the axis titles. So once you check the axis titles, you're going to realize you have some boxes that are going to appear. You can click and edit on those boxes. Like on the x-axis, we have the cells. The x-axis, we got the cells. So let me have cells there. On the y-axis, we got this daily staffing. So I'm just going to edit this, and I'm going to type staffing. Staffing. So if you want to increase the font, just highlight this, and then you can make it bold. You can as well increase the font. The same to the y-axis. Highlight, you can make it bold and increase the font. Let me just make it 12. Right. So we have this table here. We have a scatter plot here. And with this scatter plot, you can see there is some kind of linearity, or there's a linear relationship between the daily staffing and the daily sales. We can have the line of best fit in this scatter plot, because you can see the points is like they are arranged in some kind of a line. So how do we fit the line of best fit here? How do we have the line of best fit here? So I want you to go to design. Go to design, then top left, you click on add chart elements. Then go to where you put the trend line and add a linear trend line. So you're going to have a line of best fit here. The line of best fit is trying to show us the relationship between the daily staffing and the daily sales. If you double click on the line of best fit, you're going to see you'll be given the options to format that line. If you scroll down and you check on set intercept, and then you also display the equation on a chart, and you also display the R² value, then you'll have something like this. So I started by double clicking on the trend line, so that you're given these options to format. Then check set intercept, then also check display equation on the chart, and also display R squared value on the chart. So we'll have something like this. Let me exit these format options. So once you have this, how do you interpret this equation of a line? Like we are told here, y is equals to 0.0255x. Remember we said the equation of a line is y is equals to mx plus c. This is something that you were told long time ago. Mx plus c. The c was the y-intercept. And the m was the gradient, or the slope. Meaning, you can be able to predict the value of y given x. So in this case, can we really get the value of y given x? And the answer is yes. There's I had checked that set intercept to 0. That should not be the case, because you can see here the y-intercept, it is around 13 point something. So where if you extrapolate this line, where will this line of best fit cut the y-intercept? So if you click this, then the y-intercept is going to be forced to 0. So it is better you uncheck it so that you have the complete equation of a line. So now we have y is equals to mx plus c. So we can simply say you can be able to predict the daily staffing given the cells, because the cells here is the x. The daily staffing here, the maximum daily staffing here is around 980. So if you want to predict the daily staffing, given that the daily sales is 1,000, or what you need to do here is have 1,000 is the value of x. So what is the value of y when x is 1,000? What is the value of y when x is 1,000? So you can make this to be a small table here. So our borders. So this is going to be equal sign, then 0.0415 times 1,000, because the value of x here we told is 1,000. So times 1,000 minus, so I can have this in parentheses so that we follow board mass, minus 13.974. 13.974. So if you want to have a daily sales of 1,000, then you need to have around 28 people, because you can't really have 27.52 people. So you need 28 people. So we need around 28 people here. If you want to make daily sales of 2,000, what you need to do here is you're going to replace this by 2,000. And then you have around 69.0, so you can say around 70 people. This is the use of This is the use of line of best fit. It can be used for prediction. Y is equals to mx plus c.